independent. So there is something dependent variable, there is something called independent variable. That is the regression. And there the same R split into two, B. R becomes B, Byx and Bxy. And please remember, Bxy is not equal to Byx. They are not same. So generally we say R is the geometric mean of the two. The meaning of the geometric mean is make the product of the two and get the under root of the two, you will get the value of R. All the three, Bxy, Byx and R will have the same sign always. These are some of the properties of a regression coefficient. But R, as it appears, it's not that simple, because when you say the relationship between two things are there, actually there is a contribution of other things also. If I say, for example, I say there is I am teaching you, and after that I took a test and I say this is the effect of the teaching. Okay. Now, when I say this is the effect of the teaching, there are some people who have attended numerous workshops. There are the people who are the trainers. There are the people who know about the concept. So their performance will be slightly high. So how to change, how to look for that particular thing? You know, there is the effect of other variables also. Now here story becomes interesting. R, it's very deceptive. Most of the time it's very, very deceptive. So the correct thing is partial R. For the scholar's perspective, for understanding the regression, it's basically partial R. Partial R is removing the effect of the third. What is the actual relation between the two? That is what I'm saying as the real R. So in the R, there is so much contamination is there, and we have to remove that contamination. So if you look for that, you know, there is the effect of the other variable also. The other variables are called as the control variables, whose effect we wish to control. Just on the lighter side, see, I always give this example in the workshops, that we will make a study, height of Bornvita on your height, effect of Bornvita on your height, right? So Bornvita is the independent variable and your height is the dependent variable. Let's say we will conduct this study for 2 months or 5 months or 6 months. But somebody told me, see, there is an effect of age also on the height. True, age also affects. So, and then gender also affect. Boys got an average height, girls got an average height. So I passed a rule. I said, okay, tomorrow you will come and for 6 months, do bring all your luggage, everything for 6 months, but nobody will bring their age and gender with them. Keep your age and gender at home and then you come here. Now, is it possible for you? Can you keep out your age from your body or somewhere? Can you keep out your gender? No, we can't. So how to remove its effect? We cannot take away your age from you. It's all the time there, and every moment it's increasing. So how to remove that effect? So what we will do actually here, so see, 2R, please remember statistics from a different perspective. Don't think about so many techniques, etc. No, it's very simple. Just think of the friends. 2 are the biggest enemies, you can say, or these are the villains. The villains of the stats are 2. One I talked yesterday, its name was outlier. So outlier is one of the biggest. And for setting the outlier, we have kept somebody. We said, well, there is something called normality. Normality is something which will always look for the outlier. Okay. And the second part is, we call it as multicollinearity. Now, multicollinearity is again R. Multicollinearity is nothing else. It is R, but this is unwanted R. So this is the R between the independent variables. If there is a R between dependent and independent, we are very happy. If there is a very high R between independent, for sure it is going to create the problem, multicollinearity. So there we have kept one thing, for our service. What is that? For whenever outlier is there, the concept of normality will say, well, I will take care of that. Don't worry, I will check it. I will inform you. Likewise here, we have another concept that's actually a solution, not checking multicollinearity. For checking it, simply R will tell you the story if you know how to look at the R. Or there are other things like VIF, etc. But the main problem is, if multicollinearity is there, what is the way out? And we will use it at least 3-4 times in the different techniques. So that concept is called residual. Now residual is something absolutely wonderful phenomena. Residual is something that we have taken this word from chemistry. So when you burn something and what is left out, that is called as the residual. This is the word from chemistry. So what we will say, if coming back to the example of age and the height, age certainly has an effect on height, certainly, no doubts about it. But it's not that age is the only determinant of height. Nothing like that. There are other determinants also. So we will say, okay, this is the height, and age, you please come and explain as much as you can. Explain as much. So how to explain? So what is the common between the two? That concept is called as the R square. So I will explain this R square maybe in the next week in the workshop on regression. We'll discuss only and only about the regression. I will take that workshop. But here you must understand the various terminology. The terminology here says one is a dependent variable, independent variable. That's okay. Now somebody asks question, can there be more than one dependent variable? Yes, 100% there can be. But if you are taking all dependent variables separately, then these are the different techniques. But if you say all dependent variable, they together they are affected by something. Now first you need to give a logic why they are together, they are affected by that. So this particular concept enters into the zone of MANOVA. So in my playlist on MANOVA, so there's a playlist, I think its name is Beyond ANOVA. So beyond ANOVA means we can go for 2 ANOVA, 3-way ANOVA, UNCOVA, MANOVA, MANCOVA. There is so much to learn. MANOVA concept, the example I has given, that the brand name of the company and the profit, together they are affected by the advertisement. So if advertisement is good and consistent, your brand name will be, people recognize, brand recognition is there, and we assume that there will be sales also. So revenue generated or maybe profit, and second thing is goodwill or the recognition, brand recognition, together they are affected by the company, by the company's advertisement. Now this is the case. Dependent variables are 2, independent is 1. This will be case of MANOVA. If you reverse the case, dependent variable is 1, independent are more than 1. It is called as the, generally it is called multiple regression. But again, remember, multiple regression, independents need to be metric. And what is metric? Metric means it has to be only 2 are the options. It's so simple. Other than these 2, everybody else is non-metric in research. What are the 2? Reflective scale, open-ended question. Okay, so that's why all the people who are working in the sciences, they have the metric data because they always conduct experiment on the real data. Height, weight, distance, density, volume, area. So this is all the metric data when you are considering anything in the actual values. Now meaning of the actual value should not be taken as I am considering your weight 40 to 60, 60 to 80, 80 to 100 kg. I said I measured in kg. No, this is not kg. It should be measured as what is your weight, fill in the blanks, kg. So you write actual weight. That is the metric data. But if you convert into the categories, that becomes non-metric. Okay, that becomes a non-metric. See, I give you one example. I know this sort of these points, there are so many doubts in the measurement. That's why I said it requires a thorough discussion. I refer to the video of Dr. Asha Chawla. She has explained it beautifully. Let me give you an example why people, when we ask for experience, 5 to 10 years, 10 to 15, 15 to 20, is it interval data or ordinal data? So almost majority of the students, they say it's interval. You know, they say, because they say 5 to 10, 10 to 15, it's the class interval, but not the measurement. Measurement is ordinal. Please look for a very thumb rule. In the ordinal measurement, you can say this is high, this is low. Okay, how much you can't say. If you can specify how much, then it is an interval measurement. You know, our mind always jumps to directly 5 to 10, 10 to 15. We remember our PG and UG classes, we say it's interval. Yes, you are correct, but it is the class interval, not the interval measurement. What is the interval measurement? Ask yourself. I simply say A is the person who said my age is between 10 to 15. B is the person who says my age is between 15 to 20. A between 10 to 15 and B between 15 to 20. Now I am drawing certain conclusion. You just look for whether my conclusions are correct or not. I say it once again. This is really wonderful teaching online. Otherwise, I always have the blackboard in the class. So A is the person whose age is between 10 to 15. B is the person whose age is between 15 to 20. Okay. So first thing, some curious kids always say, what about the 15? Well, this is inclusive class. 10 to 15 means 10 to 14.9999. 15 is always considered in the next one. Don't worry about that. So can I make a conclusion? B is elder to A. Age is 10 to 15 and B is 15 to 20. So can I make conclusion B got high age than A? I think most of you will agree. Yes, A is in the zone of 10 to 15. B is between 15 to 20. So A is in high age than B. Okay, that's yes, we can do, no problem with that. Can I say age of B is 5 years more than A? No, we cannot say. All we can say now, by the way, if I'll ask you what is the age of A, you have absolutely no idea. You know, it's between 10 to 15. How much is the actual age? No idea. How much is the actual age of B? No idea. But whatever their age is, age of B is higher than age of A. True. See how complex things we are dealing with, and with such a ease, such a precision. We never think about it. We don't know what is the age of A, what is the age of B, but we know whatever it will be, age of B will be more than age of A. When we can say this is more, this is less, it is ordinal. When you can specify this much is the difference, that's called interval measurement. Okay, so interval measurement, we generally consider Likert reflective scale as interval measurement and open-ended questions as the ratio. Now, I told you yesterday that regression was actually made, and till date, it is actually for the both variables ratio, where 40 is 2 times 20. Okay, where 4 is 2 times of 2. Regression is actually made for that scenario. Now, think of the reflective scale or Likert scale. Likert scale says 1, 2, 3, 4, 5. Remember, we give the code strongly agree to strongly disagree. Now, does it mean 5 is 5 times of 1? Strongly agree is 5 times that of strongly disagree? No. We can say strongly agree got higher agreement than the other person. Higher, not 5 times. Okay. Do you understand? It is not apt to use the regression here. So what we will do? What we will do, first thing is, we must ascertain that whether whatever I asked, what the correct questions were correct. Were the questions correct? Did I ask the correct question? So before going ahead with such a, please remember, signs are always very simple. You know, in our society, there is some way people believe that, you know, for the science you require the very high IQ and the good intelligent people, and then remaining comes social science. Absolutely not. Absolutely not. It's totally the reverse way. Sciences are very easy because everything is defined. Every single thing is defined. Think of what is going here. Nobody knows what is going here. So that's very, very complex. It's all the brave people who deal with the social science and do the PhD also in this area. So absolutely no idea what's going in your mind, but I am expected to know what's going on in your mind and make a policy on the basis of that. So there are, please appreciate, there are every chances we will go wrong. One should not hesitate in accepting this. It's very, very difficult to understand, to know what is going on in the mind, but still we will make a try. So when we make a try, the first attempt is, I asked something and you said, you gave any idea, anything. How much you like Shah Rukh Khan? I said, I'm the die-hard fan. How do I know you are telling me correct? It may be wrong. How do I know? So I will ask some follow-up questions. Some follow-up questions, again, asking the same thing. So if you are giving again same, for example, I ask you, after some time, I ask the question, I hate Shah Rukh Khan. You must strongly say no. If you are saying yes, then I will be confused. I say, well, you told you are a die-hard fan, but you hate also Shah Rukh Khan. How it is possible? So it means I'm not asking you, you do give this response. I am saying whatever response you are giving, please be consistent on that. You should not contradict yourself. I am free. I can ask anyway, in positive manner, negative manner, this or that, but you please be consistent. If you are consistent, I believe you, I will call it as reliability. Okay, I asked the correct question, that is called the validity. So validity and reliability should be ascertained. Now there was a question about the questions like adopted scale, adapted scale, self-structured scale, whatever. please look for, when you make any scale, you have some idea. Well, people should respond this way. This is the thing. Now, when you ask, you must cross check. When you somebody say my scale is standardized, please understand what is meant by standardized. Standardized means it's common sense. You know, when I was a student, one of my wish list was I will meet this person Cronbach, because I was very curious. I was very intrigued. How come anybody on the planet do anything, but Cronbach will tell whether the results are correct or not? You know, next to God. How come Cronbach will tell every single thing? You know, ask Cronbach Alpha. Cronbach will tell. How come Cronbach know? Cronbach must have never heard about the Kurukshetra. I am conducting study in Kurukshetra, but Cronbach will tell this is correct or not. Then later when I studied, I said it's such a simple thing. Cronbach said, you know, our all Guruji, there is only one Guruji in statistics. That's Carl Pearson. Nothing above him. At par is Fisher. At par is the Fisher. And actually, you know, these two genius people, Carl Pearson and R.A. Fisher, they were contemporary in the same city, in the same years, but they were not very good friends. So their unfriendliness actually resulted in the, you know, generation of so many tools and techniques. So one thumb rule I tell you, whenever you will study about the Carl Pearson, so whom you expect, who will give, there are some deficiency in the Carl Pearson's work. It will always be Fisher. And whenever there is a Fisher, it's a deficiency will be given by Carl Pearson. So the next time when you apply chi-square test given by Carl Pearson, so look for when the conditions of Carl Pearson are not met, you will get the Fisher's exact test, and vice versa. This will happen a lot. So going ahead with that, Cronbach said that, you know, my Guruji is Carl Pearson. So Carl Pearson has given three unbelievable things, though he has given number of things. The three are just mesmerizing. What are the three? Standard deviation. Standard deviation got the same position in statistics just like heart in the body. That is one of the most important thing. And if you understand standard deviation, so many locks will open for you. The second thing is R, coefficient of correlation. And look for the question Carl Pearson actually struggled with. I will just come to this story. And the third was chi-square test. So look, what is left out? Everything is covered. Univariate standard deviation is the essence. Bivariate, it's R. All are an offshoot of R. Everything else is the offshoot of R. Whether you call it T, you call it ANOVA, you call it anything else. It's one way, it's R. And third, for the non-parametric, it's chi-square. Nothing is left out. So all basic statistics, it's Carl Pearson. Then R.A. Fisher is also there. He said, no, I have given this, you know, F test. When we say F test, F is actually attributed to this Fisher. F is for Fisher. Fisher gave this ANOVA, and then design of experiment and so many other things Fisher has given. But who was the actually a sort of mentor of Carl Pearson? It was Galton. So Galton, you may not know, but all of you must be knowing Darwin. Darwin, you know, survival of the fittest. So Darwin had a cousin. The name of the cousin was this Dalton. So he actually visited a lot of things, and this was the era one person was doing at least 15 to 20 things. So he was a traveler, he was a writer, he was social scientist, he was a statistician, he was doing this and this. And they were struggling on one so common sense thing that I want you to answer that. Carl Pearson and his mentor Galton, they were just talking, how can we know age is related to height? We know, at least for the babies, we know that there is the age of the baby and the height of the baby, and they are related. At least for babies, we know. Okay, after some time, there is no relation, but initially there is a relation. They said we know there is a relation. Age and weight, there is a relation. We know that on the BMI, on the basis of we say you are overweight, underweight. But how to put into a number? The point is, see, their units are different, isn't it? Age is in years, height is in centimeter, weight is in kilogram. So when we talk about the sciences, all sciences always say make the units as the same, because it stands on the units and a fixed system. 1 meter is equal to 100 centimeter, 1 centimeter 10 millimeter, everything is fixed. So make the units as the same, things are simple. But here Can you make as the unit same? Can we say 1 year is equal to 5 kilogram? So when you are 50 kg, you are 250 kilogram. No, we can't say this. So how to make the units as the same, and see what the marvelous idea they come out with. So for that, before that, I will ask a question to Shipra. Shipra, you can just nod, okay, because you are muted. So question to you is, Shipra, you love your father? Okay, you love your father. So Shipra, you love your father now more, or you loved in the childhood more, or it was the same? It was the same, almost same earlier also, this also. So our love to our parents, that doesn't go come down. It's not like a father while coming back bring ice cream, so I love him more. Today he doesn't come with something, so I hate you. So it's nothing like that. We love. So let's say, Shipra, we somehow we devise your love for your father and can call it as X. There is some quantity, we say it's a X. I don't know whether we will say kilogram or liter or millimeter or something, but let's call it as X units. Now what happened, Shipra? Your father got his weight increased by 10 kg. My question is, will your love also increase, or it will be same, or it will decrease? Stupid questions. So what is your idea? Same? Most of you will agree it will be same. Okay, then you are on dieting, you reduce your weight by 10 kg. So now the love is again the same, or it's something X minus 10 or X divided by 10? It's the same, X. Okay, now he put some beard, like Virat Kohli, everybody in India is putting a beard, so he put a beard. Now X plus a delta or something for this beard? No, it will be still the X. So Shipra, I have a question here, and I have this question to all of you. My question is, Shipra, when you are born, you are something like this. Today you become this, and your father, when you are born, father was something, and now he is also grown up. He is also somewhat old, okay, mature. Are you loving one particular body, Shipra, or you are loving a personality and sum total of that? Because if it is the person is not the same. Agree? The person is not the same. The person has totally changed. You have totally changed. Then how come your love is the same? Love should also change. But you say, no, my love is the same. So it's some wonderful cartoons are there. After 50 years, the wife says to her husband that I don't believe you are the same person. I want your DNA test. Because you are totally different person now after 50 years. So the point here is what we love. So maybe, Shipra, it's not the person, it's not the body. You know, I can, instead of father, I can take any other colleague, and then I can chop down some hands and legs also. Still, your feelings for that person will be same. It will not be X minus hands or X minus legs, right? The point here is when you say, I love my father, your father is not simply a body. This is what I want to say. Your father or any relation, it's overall a body plus personality plus something. So in Indian subcontinent, we devise a word for that. We say soul. So it's basically soul to soul connection. And we have decided that soul has no dimension. Soul never get old. And you know, I'm from Kurukshetra. So I can speak, soul cannot be burned, soul cannot be put wet, soul, nothing will happen to the soul. Soul is always same. When you are this much, soul is the same. When you are this much, soul is the same, right? What we will do, Shipra, we will take from the numbers, the soul out of these numbers. And this is what Carl Pearson has given. I doubt he has no idea of Bhagavad Gita and souls, etc. But he coined a term which is remarkable. The term we call in the statistics is the Z-score. Z-score, friends, is as good as the soul of this. I will just show you today that when actually you say we will find a relation between the two variables, please remember, you can never ever find relation between two variables because they have their units. Something is kg, other in the centimeter, third is in years. You can never do that. What you can do, you take out their soul out. The soul is called Z-score. Now this soul has certain property. What are the property? The first property, it will always be, this Z-score will be between -3 to 3. The numbers will always be between -3 to 3, the first property. So you will always, if anything is more than that, we will say you are outlier. You are a, some naughty person, that particular observation will be sent out. For example, I take age of these all the people here, and I converted all this. Let's say these are 168 people. So 168 people, if I take their age and I convert to Z-score, everybody value should come between -3 to 3. If something is coming 4, I will say, well, you are the, you please go out, because you are not normal. You are away from the rest of the number in certain sense. Okay, the first property. The second property, the mean of these Z-scores will be 0. The mean of the Z-scores will be 0. So when we say minus or plus, please understand, minus means from a value you are on negative side or positive side. For example, in this house, as many people are there, I will say that please think from 30. Either you are more than 30 or you are less than 30. Okay, so if you are less than 30, you tell me your age minus 30, or if you are more than 30, tell age minus 30. So for example, if I am 40, so 40 minus I will be plus 10. If Shipra is 20, she will be minus 10. Now please understand, minus is not bad. Just our psyche is minus is very bad. No. Minus here reflect a direction. Minus simply says there is a number, either you are on the left side of the number or the right side of the number. That's it. Nothing bad about it. Okay. So Z-scores get from -3 to 3. If a number is minus, we will understand its actual value would have been lesser than the mean. If there is a number with a positive Z-score, we will say its actual value is on the positive side higher than the mean. Okay, because we are taking sides from the mean, so mean will be 0. The third property of Z-score is sigma is 1. There are no variation. So all are, this is a beautiful thing, sigma is 1 for the Z-score. When sigma is 1, so that particular thing, how much away you are from this central one, from the 0, that will be made as the 1. Now this becomes, I always say, it's as good as, the physics people are proud of their equation, E is equal to mc square. This is the same thing. This value, this particular formula allows us, you can compare any damn two things. You can say there is a rocket going at the speed of a certain miles per second, and there is a bacteria moving at the microns per second. So convert it into bacteria movement also in the Z-score, rocket speed in the Z-score, both will come from -3 to 3, find out their relation. So generally in the offline workshops, we play a game for understanding. Now this is playing the game is not possible. So it's basically, I will tell you, please understand, R is not between the two numbers. Rather, technically, one of its name is product movement correlation. What that means, it simply says, when I am away, let's say me and Mahesh are doing it. When I move one step from my mean, from my central point, at that time, what Mahesh is doing from his mean, his center point. So what we do generally, we stand, like me and Mahesh will stand at 90 degree. Okay, you understand 90 degree? I am facing this, Mahesh is facing this way. So I will say, I can also move straight, go further, and I can come back from my starting point. Mahesh can also go and come back to the starting point. Now I am saying when I am moving one step, at that moment what Mahesh is doing. So basically it's, we are not comparing the two. We are saying behavior, look at the behavior. When one is doing something from its mean score, what other is doing at that moment, and simply make the product and get the average. This is called as the R. This is the fundamental of the R. Maybe I have explained, there is a playlist called regression. I advise you to watch first 3 videos of that. There I talked about anatomy of R, capital R, and the regression. Anatomy means what exactly these things are in simple meaning. If you don't like numbers, etc., then you can just see what is happening there. So the basic point is, coming back to that, we started with Cronbach alpha, and I have gone much ahead with the theory. What Cronbach alpha says, I asked a question to Shipra, 5 questions of reflective scale, and she is replying. So what I will do, I will find out R between first and the second statement, second and the third statement, third and the fourth, first and all possible pairs. All possible pair. I will find out R bar, and from the R bar, I will use a formula. It's K R bar divided by 1 plus K minus 1 R bar. So using this formula, I can find out the alpha. So if just think of, if what is K means the number of items. K means the number of statement. Let me repeat formula once again. K into R bar. What is K? Number of statement. What is R bar? Total of mean R of all possible pairs. Let me say I ask 3 statement to Shipra. So R will be between first and second, second and third, first and third. 3 R are there. Take its mean. So it comes R bar, mean R. So on the numerator side, it will be K R bar, 3 into R bar, divided by 1 plus K minus 1 R bar. So K minus 1 will be 2. So in denominator side will become 1 plus 2 into R. Now take an hypothetical example. Shipra says to all the reflective questions 5, 5, 5, 5. So R is 1. Everywhere R is 1. 5, 5, R is 1. 5, 5. All pairs are 1. So what is K? K is 4. So please, can you compute the alpha for me? On the numerator, it will become 4 into 1. On the denominator, it will become 1 plus 3 into 1. Can you see that? K R bar is the numerator divided by 1 plus K minus 1 into R bar. Now, if she is totally consistent, no deviation at all, total consistent. So what will happen? K is 4, R bar will be 1, numerator is 4, divided by 1 plus 3 into 1. Alpha will come 1. You got the idea? So how this Cronbach solved this mystery? So Cronbach didn't say that I will tell everything to you. He said common sense says that when Shipra says if a reflective scale, I am asking the same thing. There is no question on the negative. When I am asking something and Shipra says strongly agree, I know the rest of them she should say strongly agree, because these are the same thing I am asking. She say I like Shah Rukh Khan, strongly agree. I hate Shah Rukh Khan, she must say strongly disagree. Or I love Shah Rukh Khan, I prefer Shah Rukh Khan, she must say the same thing. Consistency. So we measure consistency in Likert scale. So point was this, come back to the original where I started from. I said when there are two variables and one of them is or both of them are scale, first you need to ascertain the validity and the reliability. Only after that you go ahead with applying the regression. Now when you apply the regression, how come? See, reflective scale is always that can be clubbed. Only reflective scale is always clubbed. Okay. Before that, let me answer to that question. If there is a negative wording statement, it should always be reverse coding before analysis. It's always good. You should ask the negative word statement. It's good. Once I did a study in in my previous college. So we gave that, this is a sort of survey call, something like how do you like college? The various things were given. This was what you expected, and on the right hand side, what you actually get. Perception and expectation, sort of. So what students did, students said what you expected, 5, do. What we get, 1, do. I said, well, this is not the way the questionnaire is filled. Tick, 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 tick. This is not the way. This is really bad thing. So that's why we must put some negative statement so that if somebody is filling this, do, then it is wrong. Okay, when you are written, I like Shah Rukh Khan, strongly agree. I hate Shah Rukh Khan, strongly agree. Now, no need to enter that into your system. Just, scrap that, throw that out. That's a wastage. The person is not reading your questionnaire at all. So you must change it. Now, at this point, I found a wonderful point by Professor Gaskin, such a common sense point. He says, when I ask this question scale, I take like question number 6. If you are reading this statement, make a triangle in front of it. Just amazing. It says, if you are reading this statement, make a triangle. He says, after getting the reply, I always check whether the triangle is there or not. Doesn't matter what is the shape of the triangle, big or small or whatever. If triangle is there, means person is actually reading it. If there is no triangle, there is a tick mark. Throw that out. Don't take this response. This is bullshit. Such a common sense thing, such a wonderful thing. And please don't ask me how to go data analysis of the triangle. We won't enter it into the system. It's just for the common sense thing, whether the people are actually reading it or not. Such a wonderful thing. So you just ensure people are reading it. There are some positive questions, some negative statement. Don't take all the statement of a construct at one place. Shuffle them. make it alphabetically so that people read it. That's always good. Okay, see, it's your responsibility that the people are reading. You cannot take away responsibility, nobody read. Then why you are doing research? So you must ensure. That's why we encourage a large sample. You know, in the sample of 500, it's okay. 50 people won't read, 70 won't read, but majority will read. So that again comes to the cultural part, how much society is giving importance to the research. So point here was, I have taken a long time in explaining this. So the point here was, when both of the variable are metric, but any one of them is a scale, at least one or both, first ensure reliability, validity, that is called CFA, and then go ahead applying the regression. How you apply the regression? There are the 2-3 methods. So first method is you take the sum of this, because it's a reflective construct, take the sum and go ahead with it. But this, at times there is a problem. So we go for Amos. Amos do certain calculation, or Smart PLS, they do certain calculation. The calculation of Amos and Smart PLS is not simply by taking the average and using it. It's not the same. These are totally different. So with this, now I can start with the R. I know I have taken a long introduction. There were so many questions about it. Okay, questions I will take later, because otherwise I won't be able to complete the session. So let's start with the RStudio. Hope my screen is visible to you. So this is the first script we discussed yesterday. Let me quickly go through that. What are the so far we have discussed, if you want to write it down. So after doing first, install R. Second, install RStudio. The third thing, import the file. For importing, you require any package. What are the packages? Like Heaven is there. Then the second package is read R for CSV file, read Excel for Excel file. Okay, these are the for importing. Initial 3 steps: IVA, import, view, attach. It could be IAV also, import, attach and view also, but these are the first 3 things. If you are using any file that is in the base folder or any folder, then import is not required, but just to attach and view will be required. Next thing, this is one section over. The second thing, when you start working, if there is any coded data, what is meant by coded data? When there are the MCQ questions, you would like to tell 1 meant this, 2 means this, 3 means this, binary question, you want to make this. This is called providing label. So when you wish to provide the label, the command is, there are 2 commands. As.factor will convert it into the, it will give an idea to the R that this is not the number. If you don't give any idea, R will take it as the number. Let me show you once again. I am attaching the empty cars. Okay. When you attach and the this file is already attached, so RStudio will tell you that there was already a file and this is again with the same variables, etc. So that's called a masking. So it's not an error, it's just R is telling you something. Don't worry about it. Now summary of AM. Summary of AM, see, it calculated it as minimum, maximum, first quartile, third quartile, median, etc. Because it believed 0 and 1 are the numbers. And the numbers I must calculate mean, etc., etc. But now I say I converted it to, let me increase its size a little bit. Hope it's now better visible. So I said A is equal to as.factor AM. Okay. Now if I take the summary of A, it's still 0 and 1, but now it will count it. So when you say as.factor, meaning is it's a non-metric. So what you do with the non-metric? You simply count. For the metric data, you take the mean, quartile, etc., all the things. For the non-metric, you simply count. But we are not very happy that 0 is 19 times, 1 is 13 times. If you want to give it label, this is a separate thing. As.factor is a only conversion command. Converting from numeric to factor. What is factor? Factor is a way to tell R, it's a non-metric data. It's a code, it's not a number. 1 and 0 are not the number. These are the codes to someone. Now, what are the codes? So I defined the second and one common question everybody want to ask. Can't we do it in one go? No, we can't. We have to use as.factor and second is factor. Factor A. Now this number can be changed. It can be double A, it can be A1X, anything, but this number has to be the same you have given earlier. So A, labels, only provide the label, automatic and the manual. just provide the labels. Don't provide. In SPSS we used to provide 1 means 0 means this, 1 means this. No, R says I know your numbers, you simply tell me what is their labels. So I made it as, if you want to write A, it will be overwritten on the previous one, and if I'll check it's a summary, it comes automatic 19, manual 13. Okay, so I have given, just see, first it was AM, which was numeric, then I converted without any label. When I run it summary, it's 0 comes 19 times, 1 comes 13 times, but we always prefer, instead of 0 it's written automatic, and instead of 1 it's written manual, and this particular thing is called as labels. Look for the spelling of label, L-A-B-E-L. Let RStudio do the work. You don't type first 3 alphabet, drop menu will come, use that. Likewise, I have done for VS. So VS factor, C is cylinder factor. Now I can make a table. So yesterday we worked with this table VC, and we'll get a table like this. Okay, let me do it once again, because screen result. Oh, sorry. So this becomes a sort of a table. Here the table says 4 cylinder, 6 cylinder, 8 cylinder, V-shaped engine. Whatsoever you will write first will go to the rows. If you do it like this, this is C and this is V, then it will become like this. Cylinders are here, this is there. Now one method is, this is simply the table. Let me save it in the T. T is the table, and let me write summary T. This is, I told you, iterative methodology. We will do it quite often, that whatever function is there, its output I will save into a particular variable, and then get the summary of that variable, and it will tell something else. We get the value of chi-square. I have not applied any test, but it still gave me the value of chi-square. So one, you can find the summary of that particular thing. It's called embedded function. I could have written this also, table CV. I could write this also, it will be same, but writing embedded function, if you are comfortable, then okay. Otherwise, you can do it in 2 steps. So summary T, it will give the value like this. Now, this is a very wonderful thing. We can use it a lot. Let me show you how. This file I have shared with yesterday. Maybe I have not saved it in the T, that you can do. This name was first script. Today we will work on the second script. In the second script, I'm just continuing from there. So just see, T has been created. Now I can run a function chi-sq.test. Now the question will come, well, I have to remember that. No, absolutely not. Just write chi. So it will come. And from this, just find out chi-square.test. Okay. And always provide here that table. Don't write the things here. For example, I wrote chi-square.test this. And now you can see here, it has given some sort of error also. Error means it's a warning. Warning, it says that chi-square approximation may be incorrect. Why so? Why incorrect? Any mistake in the formula? No, there is no mistake. But the assumption is violated. So what is the assumption for chi-square? There is an assumption the actual frequency, expected frequency for more than 5. So when that is violated, then R will always keep track. You know, we have not checked it. We should have checked, but we have not checked. So here R will keep track record of that. So when this is the case, what we'll do, remember chi-square given by Carl Pearson. So we come to the rescue. Fisher.test. So this comes Fisher's exact test. Okay, how to read it? Now for this, I assume you know about the hypothesis testing, etc. If no, then please remember the 2 words. The first, there is something called the null hypothesis. The meaning of the null hypothesis is, it is always the hypothesis of no relation or no difference. Null hypothesis. You remember I told you hypothesis is always the relation between the variable. Hypothesis is always and always a relation between 2 or more variable. So null hypothesis, we say there is no relation. So all statistical test and technique, they always work on the null hypothesis. Okay. So I'm not starting that discussion because it will take a long of time to discuss null hypothesis, alternative, directional hypothesis. The word difference and relation are the same. I want you to understand the word relation and the word difference and the word association. They are all the same thing as per the statistical point of view. Only thing is, when both are metric, it is called relation. One is metric, one non-metric, it is called difference. When both are non-metric, it is called association. I will once again refer to the playlist bivariate analysis, where I have explained these three words of English and the statistics associated with that, why they are different and why they are same. Please, the name of the playlist is bivariate analysis. Only 2 videos are there. So as of now, you simply remember this thing. If you are totally new, then there are a couple of things for you. We always work on in hypothesis testing or anything else, we always work on the null hypothesis. That always say no relation, no difference. No difference means whatever the differences are there, they are just minor differences. They are not major differences. They are just minor, not significant difference. The other point, how to check it? Always look at the p-value. If the p-value is less than 0.05, that's 5%. If the p-value is less than 5%, we say null hypothesis is rejected. It means either there is a significant difference or there is a significant relation between the whatever two things you are talking about. Then what is meant by this E? Don't worry about the E. It's not error or something. It's 10 raised to power. Read this E as 10 raised to power. So when it is 10 raised to power minus 5, do you remember something like indices and surds chapter? 10 raised to power minus 5, on the lower side it will become 10 raised to power 5. So basically this number is a very, very small number, 0.0000232. This is the number. So when the number is very small or the number is very large, both Excel and RStudio will make it up to 0 to 9 and 10 raised to power something. So you can just remember after the E, that is called as exponential or 10 raised to power. If there is a negative symbol, then it's a very small. If there is a positive symbol, it's a very large data, large value. So in this case, it's a very small value. So, but this says it may not be correct. So we use this. What is the p-value? P-value again comes a very, very small number. So we say null hypothesis rejected. There is a significant association between the two. So what is the association? If you want to see the association, then we can go to the percentage. Hope you are also noting down these things side by side, or I will send you one more file where I have written what to report in which test. Like when you work with the chi-square test, what are the things we report? We report 4 or 5 things. First, we report the cross tabulation. Where is that cross tabulation? So I can write simply T. This is the cross tabulation. Now look at the data. If you look here, can you see V-shaped engine is more used in the 8 cylinders and straight engines are more in the 4 cylinders? Can you see there is a data itself is telling you something? This is what is called as the significant association. So first is the table. Second is the chi-square test. Third, if chi-square test assumption is violated, then Fisher's exact test. This is the third thing. Fourth thing we give is the percentage wise we give. So I will say what percentage of straight engines are used in the 4 cylinder. So this will be 10 divided by 14. Its total will be 14. Okay. I can ask what percentage of 8 cylinders are using the V-shaped engine. So this is 100% because this is 0. So it becomes 100%. But it can be more complex. How to take this percentage? For that, yesterday we worked with, there is something called summary tools. In the summary tools, yesterday we worked with a function called C-table. C-table is the cross tabulation. C-table. When there is this sort of a red button, it means R is working. It's taking some time. It's just take time once because you know for RStudio it's activating other packages also. So it says this is, I will read it out. I will run this. That's why it takes a little time. Now I will work on C-table. Can you see this? When the moment you start writing CAT, in this curly braces, there is a summary tools. It's something like if there is more than one package, more than one function, name is same, but the packages are different. You can know which function you are working with. C-table. Now, what is the C-table? Let me work on. I was working on perhaps V and C. Okay, and nothing. If I give nothing, so it will give me by default the row percentage. It will give me the row percentage. If you want column percentage, then a third argument you should write prop is equal to inverted comma C. It will be the column percentage. Okay. So why this is helpful? This is actually very, very helpful. It will tell me, see, look at the V-shaped engine. 77% are the 8 cylinders and very less are others. Look at the straight engine, 71% are the 4 cylinder, others are less. Now look from the cylinders perspective. 4 cylinders, 90% of them were in the straight, and if you look at the 8 cylinder, 100% are there in the V-shaped. So when you study the same from the column and the row perspective, at times you got very good insights for that. But this row percentage should be reported only when there is a significant association between the data, else not. That means when p value is less than 0.05, then you should report this, else not. The fifth thing, so let me tell you 4 things once again. What are the 4 things we report? First is the table. Second is the chi-square test. If the value of the chi-square test is not okay, in that case, we go ahead with the Fisher test, else not. It means out of the second and third, anyone will be used. And the fourth will be the percentage analysis, to be reported only when p-value is less than 0.05. And the fifth thing that's optional, that's a bar plot. So see here, this is the advantage. I computed t. I'm using this t everywhere. Bar plot and t. So now I will get this bar plot. So when you want the plots better, I will take console on the left hand side, because it requires a graph on this side. So it's better we take console on this side. Environment I don't require actually. So now let me run this bar plot. We get a bar plot. I know those who are habitual of looking at the Excel, etc. They say, oh, black and white and such a faded. No problem. This is the beauty with the R. You can do anything with this. Like the command is besides. By default, this comes in this way, one overlapping other. So you say besides is equal to t. Now there is something called true and false. In R, you say I want to do it. It call it true. I don't want to do it, false. So it can be represented only by capital T or capital F. It will work. So besides true, it means I want them side by side. It becomes side by side. Then you say I want basically colors also. So call is the command. Now if you say call is equal to 2, it will be all red color. But you say no, I want all bar in the different color. But different color, there are the 3. And if you want to provide anything in the 3, remember we start with C respectively, more than 1. So if there is more than 1, then you should write it as C 2, 3, 4. And I think bracket is closed. Then it will become like this. And then you can always export, save as image, or copy to clipboard, and then you can paste it. This will come, copy plot, and then you can paste it in MS Word anywhere. This can be stated, examples, something can be written here, the legend should come, the numbers will come, every single thing will come. You have to give a command for that. But the good thing is you have to give command only once. Then rest of the time it remembers. It will just work on this. 2, 3, 4 are the colors. 2 is the red color, 3 is the green color, 4 is the blue color. If you give the 5, 6, there will be the other colors. That with the practice you will remember. Though there are millions of colors like any other software, but primary colors are like this. 1 is a black color, 2 is the red color, then 3 is the green color, etc. These are like this. So I copied it. Can I save it in MS Word? Let me check. Yeah, it comes here. So we can, if time will permit in the second half, I may work on this charts. There are certain commands for this. So there's a question, how can we identify colors by numbers? See, there are basically millions of colors are there, just like in any of the software. It's only that some primary colors are given. Like 1 is black, 2 is red, 3 is green, 4 is blue, 5 is cyan, 6 is this magenta, 7 is I think again black, and so on. But then you can give some hash. Remember that hash alphanumeric number, it will generate a new number. Or there will be some codes available that what sort of color sheets will be available. You can use any color. From that perspective, it's totally free. There are, what these things are called? These are called arguments. For example, I write main, my chart. Main is the name for heading. So my chart comes there. I want to give something in the X label. So X lab is equal to, these are the engine. So it becomes engine. If you want to give to y, so y, I write y lab is equal to, I think this is frequency. So see, when it is 1, I am using directly double quotes. When there are more than 1, I am using C, then bracket, and then other things. Frequency, the frequency will come here. You want this y-axis to be straight, LAS is equal to 1. So these numbers, can you see these numbers? They are straightened now. By default, it's 0. See, it's perpendicular to the y-axis. If you do 1, it becomes like this. Then you can put a box on it, box, it will come like this box. Well, there are certain things you can do. This you can do every single thing. Well, this is precisely I was telling you. See, if you are using Jamovi, if you are using any other software that's menu driven, there is R Commander also. R Commander, you need not to type anything. Click, click, click. But the problem is the developers of R Commander has given something. You cannot make any change in that. Now you are totally free. And don't worry about that. I need to remember that. No, you just write it only once, save that script. Whenever anything comes, open the script, click. You know what the power is. I will show you at the last. You just do select all and run. Entire thing will go into your MS Word file. This is so fast. By the time your SPSS will open, 24 versions or 25, it takes a lot of time to open. By the time you do, it's all the things are done. Just in one click, everything will go there. So script size, maybe you are not able to see this because then I got problem is, shall we do this? I hope this is visible to you. If you want to remove this, this is a short of brush, remove it. So this is the one part we have done. There is something else called a prop table. Prop table, if I'll run only this part, where is my console? Let me put console on the right side. I will put console on the left side only when I am using the charts. Otherwise, this is my input, this is my output. I will work like this. Prop.table. If I'll run this, it will change them to the proportions. It will change these weekend proportion. This equation can be used ggplot. Ggplot is an excellent thing. This is an additional thing we can use. I am using the basic one. I'm using the just commands given in the base package. ggplot, there's a particular way to write. That's why I'm not taking, it will be complex here. But yes, ggplot is just awesome. You can create wonderful, wonderful things. I tell you, see, any other software which is near to RStudio in terms of graphics is only and only MATLAB. MATLAB is a word in its own. Engineers use it a lot, but I don't think there is any other software. Well, Python can be there language wise, but R is just fabulous with the charts, etc. You can't believe what sort of chart I have given in my playlist. 3D charts also, which we can make. So let me quickly go through two things. How to reduce down the numbers. Remember in the Excel there is something like reduce the shapes, etc. Or round off. You remember round off? So I have used here as round. So I put round, the entire command I have written in that, and then 2 places. So if I'll run it, this will become up to the 2 decimal places. It comes up to the 2 decimal places. That is the round. This is the first one. So I think I can skip. There is one question about sending the output to Word format. I will do it in the last. Whenever I tell this, then it's invariably, it's always why I told to the people. Because people are stuck in it, people don't follow the instructions, and it create n number of problems. And then actually my work is increased like anything for debugging every single person. So I will take it, sending output to Word file in the last. First, let's listen to these things. So we have done first thing, working on the bivariate. I think I can remove the upper ones, this, or let it be there. The file is available with you, second script. So let me just revise this. First, we made a table T and saved it in T. We could write simply here as the summary also, SUMM summary of T. Then also chi-square test will come, or you can use chi-sq.test. If there is a warning, you can use the Fisher test. We can use the C table on the basis of proportion. If there is more than 2 multivariate table you want to make, then you can use F table. F table, the table will become like this. Can you see the V-shaped automatic 0, this. So this is first, second, and the third. 3 variables are there. You can use the F table. If you just remove the f, still it will work, but now it will be split. Table will give you output always in the two variables, but when you take the third variable, on the basis of third variable, the tables will be split. Cylinders, it's a split, it makes the three table. If you want not the three table, all in the one, yesterday somebody was saying something like OLAP etc, yes, something like that, then you use the f table. Let's quickly revise before I go ahead with the correlation what we have done. So if I'll show you that one search, okay, seems I moved it to somewhere. I'm opening that file. I gave it to you yesterday, and I told you these two are for ready reference. We will use it later. What were these things? Look at this. Now in this table, so far I have covered this. Okay, not covered this. Let's cover this. Summary tools, descriptive table I have covered, and summary tool frequency. Okay, I will cover this also. Summary tool descriptive I shown you yesterday, but let's revise it once again. Univariate, let's revise it once again. But we worked on the table and come here. Non-metric, cross tabulation. This I have covered. Summary tools, C table. What are the other things I covered in the fourth? This one, cross tabulation chi-square test. First, I made a table, saved it in T. Then I worked summary T. Third, I worked on the chi-sq.test T. Then I used Fisher exact test. The name will come automatically. Don't remember T. And then bar plot T. F table. You can down T also. You can write the arguments also. These are all related to this cross tabulation. This is complete from my side. I told you what we report. The first thing we report is the cross tab. Second thing, either of the chi-square or Fisher. The third thing we report, if there is a p-value less than 0.05, then we go ahead with the row percentage, column percentage. Fourth, we go ahead with the graph. These are the things you report. I will give you a Word file where all this I have written how to report it. Let me quickly go through the univariate, a revision of univariate once again. So let's go here, clear it. Revision of univariate. Let me go to the top. Hash. Hash means I don't read it. Univariate, and its color will change. So I'm writing here as FREQ, frequency. So frequency of what? V. So it will give me data like this. SPSS like output it will give me. Remember, SPSS gives like this: V shape 18, state is this, N means not available, any missing, not missing, there is no missing, valid, cumulative, total, cumulative, this will come. If I'll go ahead with the frequency of C, so it will say 4 cylinder, 6 cylinder, 8 cylinder, etc. This will come, and this will be directly exported to MS Word file. What about the, it's basically from this, please remember, when it is non-metric, we have to use count and percentage. When it is metric, we have to go with the descriptive. So it's DESCR. So whenever it's a descriptive always means you need to do it for one variable, mean, median, mode, standard deviation, every single thing. Find for that MPG. For MPG, it says its mean is 20, standard deviation, minimum, first quartile, third quartile, median, this, everything it will say. Okay, the details it will give like this. Well, I'm really very sorry for the noise that's coming from my end. I have problem. I also face the same problem. That's why I'm not working on the R4. I'm working on R3.6. There is some issues with the compatibility issues with the latest version with certain packages. So I will advise you, please prefer installing R3.6 instead of R4. Yesterday I shown you R4 is there, but certain packages got a mismatch. So 3.6, all packages work fantastically. There is nothing like you will lose something, but you will actually get problems with R4. Install the previous version, problem will go. So chi-square is done, and let me quickly go through now correlation. Correlation is one of the simplest. 4-5 formulas are there. Please remember where we are. I am in this segment. Both are metric. Two variables. We don't know which is dependent, which is independent. If we know, we will apply regression. If we don't know, we apply the correlation. 5 quick formula. See, number one, core, COR, as simple as that. And correlation is always computed between the two. Remember, it's a relation, and relation is always between the two. You can say, what about the 3, 4, 5? Well, they will come to that, but basic relation is always between the two. So MPG and horsepower. So it says there is a minus relation, negative. Look for, as the horsepower of the vehicle increases, its mileage per gallon, fuel efficiency will decrease. Remember that? So if you are working on the scooty, the average is something like 35, 40. If you are working on car, it's something like 15, 16. If you are working on bus, it's only 5, 6 bus or truck. As the horsepower will increase, mileage will decrease. That's why the negative sign is there. So first, a simplest formula is core. An equivalent Excel formula for that is Corel, C-O-R-R-E-L, Corel. We give the Corel array. This is core. Another formula is core.test. Core.test will go one step ahead. In the last, it will give correlation also. It will also check for the null hypothesis whether this value is equal to 0. Whether this value equal to 0. So it says t-test comes as 0.6. Either if you know the table value of t is always 2. So our rule is when calculated value is less than table value, null hypothesis accepted. Or look at this p-value, go for the same rule. If p-value is less than 0.05, null hypothesis rejected. What is the null hypothesis? Null hypothesis is that this r is equal to 0. So null hypothesis rejected, it's not 0, it's good, it's substantial. Core.test. Now, if I want to find out the correlation of MPG, HP and weight also, let's write that. It says what you are doing. Only 2 arguments are allowed, not the third argument. Okay, my mistake. When you want to make the 3, take together of all the 3, 4, 5, 10, then we can use something called data frame. Remember what is a data frame? Yesterday I told you data frame is a way to say all taken together. For example, I can say all the girls. I'm not saying Shipra or Mansi. I'm saying girls. All girls are taken together now. So data frame is put into the envelope, make all them together. So I created a data frame of MPG, weight, HP, 3. And the name of the data frame is D. And next time I will write here simply as core D. Now it will find out D not found. Okay, why not? This is D. And this is the correlation between the 3. It's not only 3. You can find 4, 5, 6. There is another variable QSEC. There is another called DRAT. There is another called DISP. These are all in the empty cars. If you wish to see, let's view them once again. Empty cars. This is the variable here. MPG, CYL cylinder, displacement, HP, DRAT, rear axle ratio, weight, QSEC. Then there is something called displacement also, DSP. So all this I have made as one data frame. Put all them in the same envelope and find everybody's correlation. So this comes, everyone's correlation is coming with everyone. If it's not clear, let me run again. Then again, I have to. Now it's okay. But again, you can see readability is low because there are so many decimal places. We want only up to the 2 decimal place. So what we can do? Round off. What is the formula for round off? Round bracket, and the last says how many places? Up to 2 decimal place. Only up to the 2 decimal place, round off. So let's run it. Now it's much better. Good. Now it's a lower triangular should be red only because this MPG HP is the same as that of HP and MPG. Correlation of RXY is equal to YX. They are always the same. So before I go ahead, anyone from the campus technology? Suman, Akshita?
Hello, sir. I'm there.
Suman, please tell me about how much noise you are facing from my side. Because is it a vehicle or shall I shift to other location in my house?
Sir, I think it is fine. I am not getting any noise. It is fine. Just sometime for a minute it happened, but then it is fine.
I'm feeling very bad because my neighbors have decided to sabotage this workshop, but we will go on. Okay.
No problem, sir.
it. So this is we can use a round off. We can just see the correlation. Now, see, I'm more interested in telling you. Only look at this table, and you should be able to tell every single thing. You know, looking from here, you can tell about the mediation, moderation, every single thing you can tell only from here. It's something like, you know, look at the pulse, and the doctor will say you got this problem. So I'm really interested in teaching you this particular thing. If you know how to look at the R, every single thing in the statistics will be so easy and so fun. You will know, okay, this will happen, this will happen. If these three will go together in multiple regression, this will happen. This all things we can do. And certainly we'll, but if you allow me, shall I show you some other things? I have not written in my script perhaps. Okay, let me write in script so that, but script I have already given to you. Good. People should be aware. They should be awake. Let me write MPG and HP. Okay, I'm doing certain thing. Correlation, you know how much is there. Let me find out Z of MPG. So here in R, it's so simple. In every other software, it's so technical. Even in the Excel, it's so technical. Here, it's simply a variable scale. Let's check it out. Z of MPG. Look, all the numbers are 0.15, 0.15. The numbers will be between -3 to 3. Some are positive, some are negative, right? So all are between this. Let's find out the mean of Z of MPG. You can say it's not 0. Well, actually it's a 0. It's 0.170, then 711. It's as good as 0. Okay, if you take for the 3 or 5 or 10 decimal place, it's a 0. Don't worry about that. It's a 0. SD of MPG, Z MPG, it should be 1. It's a 1, right? So these are the some of the property. Now I told you, let me find a Z of HP also. So see how simple it is. Scale and HP comes. Let me find out the correlation of Z of MPG and Z of HP. Any guess how much it will come? 0.77. And earlier, what was there for these? This was also the same. Okay. Now take me. One is the body MPG. Other is the soul ZHP. What will be their correlation? Same. Okay. Let's change them. One is the soul Z of MPG. Other is the body. How much it is? Same. Let's do correlation of 15,000 this multiplied by MPG, comma 0.00000 multiplied by HP. I have made one very, very small, other pretty large. If you are not very happy with that, okay, this is okay. What will be their correlation? Exactly same. Soul to soul relation will never change. You can do anything. This is what I asked Shipra. If your father will increase the weight, nothing will happen. R will be same. Don't worry about that. You do any operation on MPG, you do any operation on HP, nothing will change. Why it won't change? Basically what happens, you know, when you say find out the correlation, without telling you, every software first calculate its Z score. This is the wonder. Without telling you, first it will take this number and calculate its Z score, and it will be exactly the same which you have seen on the upper side. It's exactly the same. When you take its Z score, it's a very small number, but again it will come back to -3 to 3, and soul to soul relation will never change. So that's the one remarkable thing here. R is the soul to soul relation. But yes, this relation is little corrupt because there is a influence of others also. We have to, you know, this stupid question that I will do a experiment of Bonvita on the height and don't bring your gender, don't take your age. How to actually do that? This is what we are looking for in the statistics. This is what we will learn in the statistics. So we have done core. We have done core test little better. Core test will automatically check whether this R is equal to 0 or not. If you want to check for many, it's called a data frame. Let me do it for 3 for a reason. I will tell you. D is this. Round off, it's okay. Round off will put you up to 2 or 3. So please look for this function should be read as round whatever this thing is up to 2 decimal place. Round got two arguments. First is the entire function, comma 2. This is round can be done. At times there are certain functions they don't like round. They don't work with the round. So the second method is print. What is this method for? Rounding up. There are many things we will discuss which may not work with the round. It should, but it may not. Then the second is you use print. It will always work. 100% print will work with everything. So this will always give the output up to 2 decimal place. Either we can use round, but there are functions that don't work with round. But then print. Print is simply says on the console when you display, output of this particular thing should be displayed, should be printed only up to 2 decimal place. Don't worry about the print means printer. Now C, C++, I think they used print means show me on the console as the output. Okay, anything else? Yes, there is something called Psyche package. Let me call the Psyche package. Remember, this is the package I said it contains almost 400 functions. Let me show you this. Excellent for the people, and every single thing is contained in this Psyche for the psychology one. So it's coming because first it will populate all list of package. This is one problem. I have actually so many functions which I don't use daily basis, but I have that installed that. So it's not in a mood to comply. First this page will come and then it will start this option Psyche. Okay, don't worry about it. It will come. So let me do. I want to make a graph portion. So let me send console on the left hand side. It's available in view, pane, console. Okay, finally I get it. Psyche. When there is a checkbox, it means this particular thing has been called. Like psychometry is not called. QGraph Psi is not called. When there is a tick mark, it means you have run this and it is available. Its functions are available. These are installed but not available because there is a no tick mark. How the tick mark comes? The command is either require or library. Click on the Psyche. It says, well, these are the functions. Alpha, alpha.ci, AU, auto R, backward, practice, biscuit. These are files also. These are the functions. These are detailed list is there. 400 plus functions, entire EFA, CFA, etc. Everything is there. Complete word in its own. This is reading it is equivalent to one book actually. So let me send console on the left hand side. I want to show you a graph. We got 5-6 minutes more in this session. So this is require Psyche and the name of the package, name of the function is core.ci. Core.ci will give you some graphical output. So let me remove this CEX or something. What I am putting? I'm putting all the things in D. Do you understand what is D? D is the data frame. I want put all three correlation of all and show me the something like graphical. So it will show me the graphical. See the graph comes like this. It is called heat map. It's not available in many other softwares. How to read it? Can you see a pointer on the right hand side? So if it is positive is depicted by blue color and negative depicted by red color. The second thing, the darker the color, the higher is the value. So it's sensitive to that. For example, 0.87 is dark. I don't know whether you are able to see. 7 it is little lighter than this. 1 is perfect blue, but 0.66 it is little less lower or lighter shade is there. So now since these values are very large, some sort of protruding, so for changing this there is something called argument is there, character expansion, CEX, character expansion. So let me use that character expansion. Now don't worry about the expansion. Will it be large? No. If I'll give the number less than 1 like 0.75, so this will be reduced. Character expansion by 75. 0.75 means reduce. If I do 2, it will be very, very large. So it says, okay, the number is quite small. So it is something like readable. It's not like shouting. So these are the numbers. You can see the heat map is available. So if shall I add more of this? Let's go for DISP also and DRAT also. And then coming to here, core.ci. Now it will be 5/5. You can see 0.45 is very lighter shade of red. Others are okay. 1 is perfectly this. So this is one way. Then there is another way of showing. Another way is pairs. Pairs means, let me again do for 3 so that it's not very congested. I'm taking the 3 data frame of 3, putting together 3 pairs. Pairs is available in the base package itself. So pairs will give you a scatter plot of all possible pairs. Let's see how to read it. For this particular chart, MPG will be on y-axis, HP will be on x-axis. However, if you are reading this chart, then MPG will be on the x-axis and HP will be on the y-axis. Do you understand this? Let's read this chart. Who is there on the x-axis? Weight is on the x-axis, MPG is on the y-axis. However, if you want to see a mirror image of that, weight is there on the y-axis and MPG is on the x-axis. So you simply drop down on both of these charts. MPG is on the x-axis. In both of these charts, MPG is on the y-axis. How to read it? MPG and the MPG is miles per gallon fuel efficiency, and this is the horsepower. As the horsepower increases, mileage is shown to be going low. Mileage is going low. So what about the mileage and weight? As the weight of the vehicle increases, horsepower is increases. Positive relation. What is the weight and HP? The same. It's just the inverse of that. So what about the MPG and the weight? This is weight. This is MPG. As the weight of the vehicle increases, the mileage is going down. It seems to be a straight line can also be fit, but this MPG, it's not straight line. Can you see it's a curvilinear? It's sort of a curvilinear relation, feels better. So if you, so how many commands we have done? 5. So look for the 5 commands if you want to note it down. What are the 5 commands? Starting with the first one, COR. It can find correlation between any 2 given variables. COR.test. It will find out correlation. Also check whether it is equivalent to 0. Third, COR.CI. It will produce the heat map, okay, of all possible pairs. So how to make the pair? That is the data frame. So if you make the data frame, so more than 2 if you require, make a data frame and then write core D. So core can take 1 argument or 2 argument. If 2 arguments, name of the 2 variable, it will find out their relation, or 1 argument which is a data frame. What is a data frame? Sort of an envelope. Take all in together and give in the score. That is the 4th one. And the 5th one comes out as pairs. Pairs means make the scatter plot of all possible pair. If you want a scatter plot of any one of them, I think we can write simply plot. Plot MPG weight comma MPG. This comes like this. Just like the Excel, the rule is whosoever you will write first will go to the x-axis. Whosoever you will write first will go to the x-axis. This is a rule like Excel. So plot will come, but if you want many plots, rather all the plots simultaneously, then the name is pairs. And in the pairs, we give a data frame. So this is our first introduction with the data frame. Hope it's not that tough. And it's okay that, you know, it initially may take that you are writing, but I am again requesting you, dear, you are also writing in Excel. Excel is not reading your mind and automatically typing. 3 alphabets you have to write. And if you say, well, you have to remember, I tell you, it's just maybe it's less than 3 hours we are discussing with RStudio. So initially when you learned Excel, it took you a lot time, and SPSS, you are going crazy while learning SPSS. It's just 3 hours, so take it little slow. Don't hate it as of now. So RStudio is simply fun because now the beauty is this is available with me script. Now I want anything else, I will just do this and see the beauty. Control Enter, all the things will come. This output is there and all the output is here. And not only output here, it will go directly to the MS Word. So actually the real power comes here. You write a command, then somebody say, I want this, no problem. Just first activate that sync, which will send you the Word file. Select all, press enter, the file is prepared in the MS Word. So that's so simple. In the other software, you just click, here the work is done. It will send in this. This is such powerful. And data of 10 lakh, 50 lakh, no problem with it. Absolutely no problem. I recently met a student. He was working in AIIMS. So he said, I want to just make a simple thing. He said, my data is of 1 crore. So they are actually, AIIMS means they are doing research, and that's a several year data. So he said, I take a small data of 10 lakh. So he was trying to work on that. He shared with me the Excel file was something in GB. Excel file was something in GB. When I worked on the Excel, every time Excel will hang, it won't work. RStudio, absolutely no problem. Click, done. It's so powerful, so powerful. So is there a difference between making chart and Excel and R? Absolutely not. The commands are different, little bit here and there, but otherwise chart will be the same. When the data is same, how can the things be different? It's something, you know, asking the question, I got a Casio calculator, now I change some other sort of calculator, 5 into 4 will be same or different? Changing the company will not change the calculations. So it's the same. There's no difference in that.